Again, let's look at the region for 89, and I'm going to say, the lower limit, y is equal to x, rather easy to understand, and the upper limit is y equals 2. All right, let me draw a picture of that. And this looks sort of like this over here. That's y equals x. Y equals 2 is sort of like this over here. Now let's do the x equals 0, and upper limit's going to be x equals 2. So I'm seeing if it goes from 0 up to 2, I'm seeing this region over here. All right? Now before I go on, I want to point out, it looks like a pretty nice region. My question over here is, I wonder, if we're drawing the same pictures over here, and we are. My concern is I wonder, do I really need to, change things around? And I'm going to look at it first, and I want to see if I can work on the integration. So I'm going to do that inside first. And let's look at that. No, I don't think I want to do that. I want to change the limits around. All right, so I'm going to erase this, and I'm going to try again. I'm going to get that picture again, this over here. I'm just putting down some points here for you. All right, that's a 2. So let's take a look at it. And what I'm going to do is just change this. I'll write this over here, x, and I'll write this over here. And I'm going to put a dx first, because I think it's pretty easy to integrate that. Now, if I'm doing that, I'm actually just, where does the x start? Where does it stop? It starts at 0, and it stops right over here. And what would that be? That would be, x would be y. All right? Make sure I said that right. 0 up to y. All right, let me do that integration. Again, maybe I should write down the full integration before I do that integration, so I'm clear about that. This is going to be dy, and the y, let's take a look at that. It's going to start at 0, and it's going to go up to 2. All right, now let's do this. I want to pull what I'm doing over here. I'm going to do this first. Looks pretty simple. I'll write it down. It's going to be x squared over 2, the root of 1 plus y cubed, evaluate from 0 to y. And this is the x value, by the way. What do you get? Y squared, 1 plus y cubed over 2. And if I plug in 0 for x, I just get 0. So let's write this down, 0 to 2. I'm going to pull out the half, and you get y squared, 1 plus y cubed dy now. I can make a u substitution. I'm going to say u equals 1 plus y cubed du is going to be 3y squared dy. Let's go for that. So I still get a 2. If y is 0, u would be 1. If y is 2, I'd get 9. Let's see, the root of 1 plus y cubed is the root of u. I'm going to put u to the 1/2 down. And then y squared dy is 1/3 of a du. Think I can do that. You can get 2/3. I'm doing this over here now. You're going to get u, and I got to increase the exponent by 1, so 3/2. Divide by 3/2 or multiply by 2/3. Limits of integration are going to go from 1 to 9. I want to point out, I'm seeing some things over here that I think it's good to simplify. It's 4/9. And u to the 3/2 is really just u root u, and 1 to 9. Let's do the 9. It's 4/9 times 9, and the root of 9 is 3, minus 4/9. The root of 1 is 1, and 1 times root of 1 is 1. So I'm going to put a 1 over here. What do you get over there? Well, I'm going to pull the 4/9 out. And you get 27 minus 1. which is 26, and 4 times 26 over 9. Let's write that down. That's 80 and 24, 104 ninths. All right, let's hope I didn't make any mistakes. And I think I made a mistake somewhere. And I got to really think about the work and see where I made the mistake. And let's see where I made a mistake. So I got the 1/2 0. Let me see if I got the integration set up right. So this is what we're looking at over here. Did I do that right? So 0 to y. Yeah, x, 1 plus y cubed dx dy. 0 to 2, I got that. Was able to do the integration correct. Let's see, 1/2. 0 to 2, y squared, 1 plus y cubed dy. I got that correct. Was able to get that u part done. And you know, I'm looking at this over here, 1 to 9. I hope to see that. I do see that. I do see the root of u. And then I see a problem here. And I think I see it right away. All right? I'm going to back up over the work, though. And someone says, why do you do that? I don't want to do it all over again. I want to just correct where the error is. The error is over here. Let me erase all this business over here. All right, let me get this and clean it up a little bit. All right, I wrote down 2 when it's actually 1/2. That was a big problem there. Let's do this again, though. So u is 1 plus y cubed du is 3y squared, dy. So what do you get over here? You still get 1/2. When y is 0, u would be 1. When y is 2, u would be 9. What do you get here? Well, 1 plus y cubed, the root of it, is just u to the 1/2 power. And then the y squared dy is 1/3 of a du. Now 1/3, when I pull it out, it's going to make this a 6. All right, let's do the integration now. And what do you get there? Again, we're going to do this over here. 1/6 u, increase the exponent by 1, so 3/2. You're going to divide by 3/2 or multiply by 2/3. Limit to integration and going from 1 to 9. I want to clean it up. And what do you get there? Looks like you get 1/9. Again, 2 goes to 6 3 times. 3 times 3 is 9. You get u, root u. 1 to 9. Let's do that. What do you get? 1/9. You get 9 times 3, which is 27. Minus, when I plug the 1, I get 1. So what do you get there? 27, 26 ninths. Let's see, oh, there it is. We did it right this time. So I'm glad I did it right in the second try, but in the first try I did make a mistake. And my mistake is I wrote 2 down there when it was actually 1/2. I'm not sure how that happened. Maybe just poor thinking about the problem. Thank you.